This deep dive is all about disruption. I mean, the kind that can fundamentally change an entire profession, seemingly overnight.
Exactly.
For the last, 2 decades, software development was just defined by this escalating complexity. Sprawling tech stacks, specialized teams.
Right. And that world, the world of manually configuring everything, endless YAML files,
Yeah.
it's dissolving.
It is. We're seeing this monumental shift in what it means to be a software developer, and it's all being driven by AI building our UIs and apps for us.
And this isn't just a new tool, it's a completely foundational change. We're drawing on some really interesting source material today, specifically from a Stanford CS class, fall 2025.
Oh, that's fascinating.
Yeah, and it frames the shift perfectly. It's about moving away from what they call vibe coding.
Vibe coding. I love that term.
Me too.
It just perfectly captures that feeling of, wrestling with configurations that change every 6 months or just writing code for the sake of it.
It does. And so our mission today is to really get under the hood of this transformation. How do we go from needing a huge team to manually build these complex web stacks to just prompting an AI?
And getting reliable functional code out of it almost instantly. That's the key, right? The reliability.
Exactly. We need to unpack how systems like Vercel's V0 actually pull that off.
Okay, so to do that, I think we have to start by really appreciating what you called the old days. Because if you don't understand just how punishingly complicated development was, you can't really grasp how radical this AI solution is.
That's the core point.
Yeah.
It was an economic tax on every single bit of innovation.
So let's think back. What did that sprawl look like? We had the LAMP stack.
We did. The foundational stack, Linux, Apache, MySQL, and then PHP, Python, or Perl. A bit bulky, but you knew what you were getting.
Then everything pivoted to JavaScript, which gave us the MERN stack. So MongoDB, Express, React, Node.js.
And that MERN architecture is a perfect visual of the friction involved.
Yeah.
You have the user interacting with, say, a beautiful React app on the client side.
Right.
But that app can't do anything important on its own. It has to talk to the server side, which is Express. Express then acts as this middleman, handling all the requests just to get data from the database MongoDB.
It's a multi-layered conversation that had to be choreographed perfectly by hand.
Meticulously. And if any one of those layers changed, the whole thing could break.
And then things got even more complicated when you wanted to scale or just modernize. We got Jamstack, serverless architectures.
And the diagrams in the sources for those environments, they genuinely look like city maps, just spaghetti diagrams of dependencies.
So a single modern site back then would have, what, a static site generator?
A static site generator, maybe a couple of different headless CMSs for your content, multiple CDNs for speed, and then this whole thicket of cloud functions on AWS or Google Cloud. It was just relentless integration work.
The AWS serverless diagrams are the most frightening. It wasn't just about code anymore. It was pure infrastructure.
Exactly. You needed an entire orchestration layer for everything. Let's break that down for the lead.
Yeah.
So you needed AWS WAF for security, so the bouncer at the club door, then API gateway just to manage all the routes for your services.
Okay.
Lambda functions were the little bits of code that actually ran your logic. DynamoDB was for storage. And then you often needed Cognito, which is another service, just to handle who's allowed in and what they can touch.
And the final piece, CloudFormation, which is this massive specialized blueprint you needed just to deploy the whole thing.
An incredibly brittle process. It demanded deep expertise in just infrastructure. Before you even wrote a single line of application code, that was the economic drag. That manual configuration was the primary blocker to speed.
Which brings us to the first real attempt to solve this problem. The first wave of automation, right? The visual low-code and no-code platforms. We're talking about Wix, Squarespace, Webflow.
They definitely made things easier for, small businesses or portfolio sites, but they had some pretty severe limitations.
Their customizability was never really there, was it?
Yeah. No. You'd hit a wall pretty quickly. And the code they generated was often bloated, unmaintainable, just not truly production grade.
So they solved one problem for a small market, but not for complex applications.
Exactly. This second wave, the new AI world, is completely different. It's not just a visual layer on top. It's an engine that generates the professional-grade code base itself.
And the number of tools that have just flooded this space, the source material calls it a Cambrian explosion.
Which is a perfect description. You've got Lovable, Replit, Base 44, and then the big systems like Cursor, Claude Code, and of course Vercel V0.
The key outcome here being the ability to, as you said, prompt your way to a fully fledged app.
And that's the real democratization. anyone can generate the initial scaffolding. And what's crucial is that these tools output clean React or Next.js components, so they're actually extensible, unlike those first-gen platforms.
So if these agents are handling all the component generation and the boilerplate, what does that mean for the engineer? What's the human's value now?
Their value just shifts dramatically up the stack. The Stanford lectures note that engineers become more cross-functional by necessity.
So less about the how and more about the what and why.
Precisely. Their job isn't to manually code a button anymore. It's to be the chief architect, the translator of a vague business need into a precise agentic instruction. They're the bridge between engineering, design, and product.
Okay, so let's unpack that central mechanism. How does a system actually take a prompt like, build me a dashboard with a dark mode toggle, and turn it into real working code? This whole process just accelerates that fail fast, fail often idea.
The acceleration is built right into the workflow. Gaspar Garcia, who's cited in the source material, lays out a very clean four-step process for this.
Okay.
Step 1, natural language input. You just describe what you want. Step 2 is the AI processing, where the models generate the code. Step 3, and this is key, is the live preview. You instantly see the interface and can iterate on it.
Often just by prompting more changes, right?
Exactly. And then step 4, one-click deploy. No more fighting with all that manual configuration we talked about.
It sounds like magic. But the real deep dive is inside that engine. How does it handle that fuzzy translation from human idea to structured plan?
Well, it's a highly structured 5-step workflow, which really highlights the idea that agents are workflows, not just a simple prompt box. The complexity is hidden, not gone.
All right, walk us through those 5 steps.
Okay, so step 1 is intent understanding. This is where the NLP engine really goes to work. It takes your conversational input and extracts structured requirements.
So it's identifying components, layouts, data flows. It's making a blueprint.
A precise build manifest. Then step 2 is context assembly. Before writing a line of code, the system gathers all the relevant info, your design system tokens, any existing components it can reuse, API schemas, accessibility rules.
Which is what stops the code from being generic. It makes your code.
Exactly. Then you get to step 3, code generation. This is where the LLMs generate the actual production quality React components using proper TypeScript for safety.
And there's a validation step in here too, isn't there?
Step 4, validation and testing. This is happening automatically in the background as the code is being generated. It's checking for accessibility, responsive design, and general code quality. It's checking its own homework.
That's incredible. And the 5th step?
Step 5 is the human in the loop. This is critical. The engineers using the tool review, refine, and provide feedback. And that feedback is used to continuously train the model for the future.
This whole process brings up the single most critical challenge: reliability.
Right.
LLMs are probabilistic systems. They're just guessing the next word. So how do we get error-free code that we can actually ship to production? Especially when the model's knowledge is months out of date, but React had an update yesterday.
This is the engineering marvel that separates these specialized platforms from just using a general-purpose chatbot. They realized you can't just prompt your way out of that limitation. You have to build quality control systems around the model.
And they use 2 main strategies for that. The first one is stream manipulation.
Stream manipulation. It sounds very technical.
It does. What is it conceptually? Is it just hiding the bad code?
That's a great question. No, it's quality assurance. Think of it like a QC checkpoint on an assembly line. The LLM starts generating its code, but this subsystem intercepts that stream of code before it ever gets to you.
Okay.
And it fixes common, known errors on the fly. It's like an automated spell checker, but for specific framework pitfalls.
Give me a real example. Where does an LLM mess up that this system would catch?
The sources have a perfect one. An LLM might generate an import suspense from next suspense.
Okay.
That's just wrong for the Next.js framework.
Mm-hmm.
Suspense has to be imported from the core React library. The stream manipulation subsystem sees that known bad pattern, deletes it from the stream, and injects the correct React path.
All before the user even sees it.
All transparently. The user just sees perfect, working code and a correct preview. It prevents that immediate frustration of getting broken code.
That is genuinely ingenious. It accepts the LLM's flaw, but delivers a reliable result anyway.
Another great example is with icon libraries, like Lucid React. They update constantly. An LLM trained 6 months ago will try to use an icon that doesn't exist anymore. Stream manipulation catches that and substitutes a valid alternative.
So that's the first line of defense. What's the second strategy?
That would be the sophisticated use of autofixers, which are powered by training and fine-tuning. And they have two approaches here.
Right.
The first is real-time. They use fast, cheap LLMs, smaller, optimized models running in the background to detect what they call silly mistakes.
Like missing brackets or lazy code.
Exactly. Simple syntax errors. So
Yeah.
you have a hierarchy of models. The big creative one generates the code, and the small fast ones police the details.
And the second approach.
So second is more data-driven and long-term. They store the common mistakes that actually happen in production, real-world errors, and use that data for reinforcement learning to fine-tune their open-source models. They're specifically teaching the model not to make those common production errors.
And the data shows this works. The comparison numbers and the sources are pretty striking.
They really are. A specialized model like V01.5 Millidia hits a 93.87% error-free generation rate.
Which is just so much higher than the general purpose models. What were they? Claude 4 Opus at around 78%.
And Gemini 2.5 Flash down at 60%. That optimization pipeline, the stream manipulation, the workflow, the autofixers, that's the real difference between a sum demo and a tool you can actually use for work.
So let's connect this back to the industry. We talked about this Cambrian explosion of AI dev tools. What does this mean for companies? Where should people be focusing?
Well, the landscape is breaking into categories. You have your code assistants like GitHub Copilot that just help with autocomplete. Then you have front-end builders like V0, which handle whole interfaces. You have testing and QA tools and DevOps automation.
And you said earlier the key differentiator to look for is the ability to handle end-to-end workflows.
Absolutely. You don't want a slightly better autocomplete. You want an agent that can take a feature from an idea all the way to deployment. That's where the huge efficiency gains are.
And companies are adopting these agentic workflows really quickly. How does this translate into actual business value?
The source material breaks it into three buckets. The first is startup velocity. Startups are shipping MVPs in days, not months. It dramatically cuts the cost and time to validate an idea in the market.
Which means they need less seed capital to even get started.
Exactly. The second is enterprise modernization. Big companies are using these to prototype internal tools and customer-facing features way faster. An internal dashboard that might have taken a team 3 months can be prototyped in a week.
Can you give us a quick hypothetical of that?
Sure. Imagine a bank needs a new dashboard to track regulatory compliance. Before, that's weeks of meetings, design mocks, a full MERN team. Now, a product manager can just prompt the requirements, get a working prototype in 48 hours, and get immediate feedback from the compliance team. The tech is no longer the bottleneck.
And the third bucket was agency efficiency.
Right, which is all about speed and client feedback cycles. Agencies can deliver fully interactive prototypes within hours of a kickoff, not weeks. They're seeing like 5 times more concepts per sprint. Clients are happier because they're interacting with a real thing, not a static image.
So, to summarize the big takeaway here, app development has moved on from that manual vibe coding world. We're now in an era of sophisticated AI agents managing the entire workflow. The developer's most valuable job is no longer building the component, but architecting the initial idea.
Which brings us to the final provocative thought for you to take away. If the speed of development is accelerated this much, technical complexity basically disappears as the main constraint on building new things.
Right.
The new bottleneck is simply the quality of the initial idea itself. The source material notes a harsh truth, that most of the time, a user's initial idea most likely isn't great. So the question for you to think about is this. If AI lets us ship ideas 5 times faster, how much faster will the market let us discover that our idea was flawed? The value has shifted entirely from execution to validation and strategy. And that is where you need to focus.